Thanks everyone. Good afternoon everyone. My name is Venkat Pula. I need to put this. Yeah, my name is Venkat Pula. I'm a pre-sales engineer from Talend. So I'm co-presenting with my ex-colleague. We were actually colleagues back in IBM, Jack Carlson from Snowflake. So from an agenda perspective, right? So what we are going to do is that I'm going to give you a quick overview of Talend. Okay. Again, all of you are Talend users, so my focus is about like why Talend in your organization as opposed to who we are. Okay. And then as you're all using a part of the Talend, like I want to show you what is coming new in the Talend today, and then because today's focus is about how Talend integrates with Snowflake, we have a couple of integrations, one with using Stitch. How many of you know Stitch? Okay, so that means that we can talk a little bit more about Stitch, and then also we can integrate to with Snowflake using Talend Studio. So we'll talk about like when it is appropriate using Stitch versus Talend Studio, and then I'll hand over it to Snowflake, that's Jack. Okay. So the first question is that why Talend at your company, right? So here is the Talend integrated value chain, where on the left-hand side you see like all your sources, etc. are there, and on the right-hand side are your targets. And when you're moving the data from whatever sources to targets, right? So this is where majority of the time is spent. According to Gartner, this is about like 60% of time and cost is spent on this integration process. Now, what we want to do is that we want to cut down the time to integrate and cut down those costs. That's exactly what we are trying to do, and that's where Talend comes into play. Now, so that you are converting your data into information, so that way you can have ready insights. Now, we have several different capabilities in Talend. Okay, so this diagram kind of looks awkward. That's because not because of marketing people, but I made those ugly looking changes, okay? Because I'm not really good with you know, like pictures and things like that. So, but the thing is that like on your left there are like two parts, right? Stitch data loader and data integration. So these are the things that we are going to do a little bit deeper dive today. And the other capabilities that we have are like data quality, meaning like profiling your data and understanding the quality of your data and building rules and making sure that your data is matching your business rules, etc. And then the red ones are, the ones in the red circles are like our new products that came out in last 1 year or so. I'm going to go a little bit detail later on. Like in Excel, we have macros, right? So it is kind of like a macros. We use the term recipe. So that recipe can be exported and it can be imported into Studio. So once that data massaging is done, that can be taken and implemented in Talend Studio. Okay, so it's kind of a service application targeted for data analysts. And then the data stewardship is all about the data that I have is something that I have to live with, but there are certain problems in this data. So I need to fix this data, probably because maybe my product code has changed, or maybe we came up with a new insurance type or something like that, because of which we need to change the entire scheme. Okay? So when we are doing all of that, this data needs to be curated, this data needs to be fixed. That is what this data stewardship does. So whereas in data preparation, it is think about you're making those changes by using something like a formula or something like that at a column level. This one you're actually making changes to individual rows. So where you're saying that, oh, Venkat Pula, okay, so he used to live in Burlington, Massachusetts. Now he moved to Andover, Massachusetts. So let me change his update his address. So that's the kind of changes that you will make in data stewardship. Now, for remaining three, right, so these are the new innovations that came from Talend in past 1 year. The very first thing is that what is hot today is Talend Cloud, our pipeline designer. Okay, so this pipeline designer you can think about as Talend Studio in the cloud. Okay, but it's not there yet. Okay, as in terms of all its functionalities, it is our first step into moving into cloud where you really don't have to use a studio, a client-based application anymore, but rather build these applications right within like a browser. Okay. So with these, right, so you have several different capabilities that are we are adding into this, such as like a live preview, schema on read, and if you have any. Sometimes when we talk to our customers, like they have some hand code like Python, etc. So you can bring in the Python code and so on and so forth. So this is we released it actually less than a month ago, and it is available for all our existing customers. So probably you can also take, especially if you are a cloud-based customer, it is available for you. You can take advantage of this. Then we also have something called data catalog. Talend data catalog is all about bringing the governance and trust to your data. So that means that as part of data governance, what you are looking at is that what are my critical data elements in my organization? Okay, where is this data coming from? Can I trust this data? If I am looking at this data, let us say I am looking at a Tableau report or a BI report, and I am saying that, okay, so where is this number coming from? Okay, can I, so show me the entire data lineage, where the data, what all sources this is coming from, and how it has transformed in the journey from its sources to target. So this is the type of questions that are addressed using Talend data catalog. So the way the Talend data catalog works is that it can connect to any type of sources that you may have. So whether it is databases or ETLs or big data or any type of metadata sources, and brings in that metadata, and based on that it can start cataloging the data. So that, and because now you are bringing this data and actually sharing this data with your business data analysts, if at all there is some data that is private data, you can actually mask the data, like like you can look at the data and actually mask this social security number here, for example. And then you also have the data profiling capability here. So this data profiling capability, if you have used Talend Data Studio, there is a data profiler in there. The purpose of the data profiler in the studio is about trying to figure out how many null statements, like how many null fields I have, how many blanks I have, how many duplicates I have, and things like that. Whereas here in Talend data catalog, the purpose of profiling is different. Here I want to understand what is the type of data that is there. Okay, so if there is a column called first name, but is it really like name, or what kind of data is there? So maybe in this particular actually my where is my mouse? Actually probably I can just go here, right? So here whatever that first name is there, here it can say that there is 94% chance that it's the first name, 50% chance that it is city, and 41% chance is that it's a last name. So that kind of a data profiling capability that is there, and now you can understand, oh, this is the type of data it really is, independent of, irrespective of the column name that is given there. Okay, so that kind of profiling can be done, and then you can also build the end-to-end data lineage. So that way I can understand where this data is coming from, or if I make a change to a particular column in a particular table, how it is going to impact downstream. Okay, so you have a both ways data lineage. The third capability that we brought into table last year is the cloud API services. We actually acquired a company called Restlet back in 2017, and we have enhanced, using the Restlet, we have enhanced our Talend data services capabilities. Now, do any of you use our ESB capabilities, data services, by any chance? Not yet? Okay. So essentially what it does is that we actually provide a complete environment for you to design APIs, okay, in the cloud, okay, using a web browser, and then implement those API services in Talend. If you think about Talend, right, majority of it is when you're doing ETL jobs, most of them are batch jobs. Okay, so that means that it starts, runs the job, and completes. But whereas here, if you want to keep running this job 7/24 as a service, right, as a web service, so where maybe someone is actually querying for some kind of a data, right? Think about maybe someone wants to get a price quote for some kind of insurance product that you have. So they send a request, and then you, as a result, you send the response saying that, okay, this is the price quote for this maybe this insurance based on gender, age, smoker, non-smoker, like that, right? All of that request and response methodology can be implemented using this. Okay, so when we brought this here, right? So the primary goal is that now you can actually start monetizing the data that you already have, so that way you can actually serve data as a service to your end customers. So that they could be internal customers, external customers, partners, suppliers, vendors, it doesn't matter who that is. Okay. To do that, what we did is that we have an API designer in the cloud, and we have expanded our Talend Studio offering to support this API designer, and we also built a tester in the cloud, so you can actually test your API service calls. Now coming to the main portion of today's discussion. As I said, right, one of the value, again, Jack is going to talk a little bit more in terms of the value of Snowflake, why Snowflake, and what are the advantages of Snowflake or as a data warehouse in the cloud. But when you want to make use of the Snowflake, right, the first thing that you need to do is that you need to move your data from whichever sources that you have into cloud. Now this can be done in two ways. Okay, so one is that I have some sources and I just want to move this data. Okay, there are no transformations required. Okay, it is just a replication of this data that I want to do, maybe on a constant basis. So if you want to do that, that's where like Talend Stitch comes into place. Now Stitch is a company that we have acquired actually like at the end of 2018. And Stitch provides about connectivity to about 90 different data sources. And these data sources are not only traditional databases, but think about your Facebook, Twitter, or any HubSpot or things like that, right? Any new age data sources, okay? All modern data sources it can connect to. And then it can actually like start moving the data. So here, when you do this, right? So you can actually start loading the data within about like 5 minutes or so, and it can scale to different level of volumes. Okay, so I'll just go into a show and tell about the Stitch. So here is Stitch, a Talend company. Okay, so once you sign in here, okay, you can actually sign up for free, and you can get some integrations for free. Okay, so here once I sign in, I can create several different integrations. So, for example, I can say like add integration, and then all of these integrations are available. Okay, so as you see, like some of them are free integrations and some of them are paid integrations too. Okay, so I have already integrated MySQL. Okay, I have a MySQL running on my EC2 system. I want to use this as a source. Okay, so when I click on this, the settings are, all I need to do is that once I create this, right, I need to provide the information about where the host is, what's the port number, and the user IDs, passwords, the database name, and if I want to do any log-based replication, okay, and the replication frequency. Okay, if I want to replicate it, okay, whether I can do it like every minute or every 12 hours or 24 hours, you have ability to move in any way. And then once you set it up, then you pick the tables to replicate. So it actually connects to the source, and it brings out all the databases. Okay, and here like I have this particular database, and then I'm actually replicating a couple of tables here. Okay, if I want to, I can pick another table and then finalize my selections, and then it starts replicating the data. Okay. So in this particular case, what I did was that I actually, my target, like once I define the source, my destinations also I can define. So here in this case, my destination is Snowflake. Okay, so it's actually checking if I actually have a valid destination, and it actually based on my host name. Okay, so which I mean like my URL and user ID and database and warehouse right? So once I gave that information, it actually validated this, and now if I go to my, and it starts doing the replication now, okay? That's it, okay? So there's no studio involved, there's no software involved, there's no hand coding involved, nothing, okay? This is it. And then once I go to my, here is my Snowflake, okay? And if I refresh this, okay, I have my database here, okay? And Venkat database, and in there I have this MySQL on EC2, okay, and these are the tables that are being replicated, and that's they appear here. It's as simple as that, okay. Now, so now coming to Talend, right? So Talend is a much more powerful tool in terms of, especially like if you really don't want to move the data to Snowflake directly, rather you want to do some kind of a modifications in this one, right, as part of ETL and things like that, and the result you want to push to Snowflake, that is when you start using Talend. Now, this part probably like I don't need to tell you because you are all already Talend users. We have a graphical UI environment, we can connect to, we have a shared repository, and we can do all sort of data profiling, it is there, and we have centralized scheduling, and we have load balancing capabilities, and all of these capabilities are there. And whenever you want to use all these capabilities as part of your build, right, so as part of your data pipeline movement, that's when you start using Talend Studio. Okay. In this particular example, what I'm doing is that I have some kind of a file that is coming in, like it's some third-party customer data, and I'm validating with some product database, okay, and here is my mapping routine. All of you know what I'm talking about, right? Okay. And these are the valid records that I want to move to Talend, to Snowflake, okay. So when I'm doing this, okay, so here I have several, if I start typing in Snowflake, as you know, like we have several different components that you can use to connect to Snowflake as Snowflake input, output, bulk exec, etc. So in this particular case, I'm using Snowflake bulk execution, okay, and once I run this job, it can actually move the data to Snowflake, okay. So, and then the other capability that we have, so here in this particular case, we are moving this data to Snowflake on like maybe like one table at a time, right. So in case if I want to do replicate stitch equivalent within Talend Studio, we can still do that one also. Like say for example, in this particular, I have an example here where I am actually connecting to a source database on RDS, okay, so Amazon, it's actually sitting on Amazon. So once I connect to both Snowflake and the source database, I'm actually like getting the list of entire tables from a database source, okay, and once I got the names of those, I'm bringing in all the data, okay, for each row, right, I mean like for each table, and I'm replicating that table on the Snowflake, okay. So in this particular case, when I actually let me refresh this. So here right now, this is the list of my tables that I have right now in my Snowflake. Let me refresh and confirm. Okay, so these are the tables I have right now, and once I start running this job, okay, it will take about like 3 to 4 minutes to run this job, but what I did was that there are like too many additional components that you see, like a chronometer start and chronometer stop and print and console, all of this. But essentially what I'm doing is that I'm actually figuring out like what all tables are being loaded and how long it is going to take, and you know, like the performance, right. So if so here if you see, I don't know how, if you are able to read it from the screen or not, but say for example customers table, it has about like 1818 records, and it took 67, I mean like it passed at 303 rows per second, whereas the more number of records are there, okay, so it's 1818 to 10,000, it came, the ability to move increased to like 2,000 rows a second, and then we have about couple of more tables like 200K and 500K and 1 million, and there you'll see like the processing speed would increase to, like I say, like in this particular case, 10,000 rows per second, and then it would be increasing further up. Okay, and once this is being done, if I actually go here and I refresh this data, right? So here are my new tables that are coming in: clients data, customer data, 7 members, 10,000 members, 20K. All of that are available. And if I want to quickly say like preview data, I can take a look at some of this data here. Okay. So this is how like you can integrate again, like my goal is to show that it's very simple to integrate Talend and Snowflake together. You have multiple choices, okay, one with the stitch data. If you really are not doing any kind of ETL processing in between, and if you want to do ETL processing, Talend Studio may be a better option for you. Okay. So at this point, what I'm going to do is I'm going to turn it over to Jack to pick up where we left off, and then after that we both will be available for Q&A.
Hello, everybody. So Venkat just loaded up this tool that I'm particularly fond of called Snowflake. So why don't we learn a little bit more about what that is, huh? So Snowflake is a data warehouse that was designed from the ground up to exist in the cloud, and just a little bit of background on why we even exist in the first place, I think helps folks understand what they're really looking at here. So this slide right here really illustrates the kind of world that we walked into when we started building Snowflake back in 2012. And a little bit of background on that. We were founded in 2012 by a couple of ex-Oracle guys. They were actually the chief architects of Exadata. I have a little bit more on the history coming up, but suffice to say, 20 years of experience and their minds being polluted by seeing what's available in the cloud, they really thought there was a better way of doing things, and we like to think we found it. So this is the state that we see day in, day out with customers, either with on-premise data warehouses or even cloud data warehouses in the cases where they were on-premise solutions that have been migrated to live in the cloud instead. So first and foremost, siloed and diverse data is something we see constantly. There are multiple systems in place. Perhaps there are multiple sources feeding into a warehouse. Perhaps some of that data is not necessarily immediately data warehousing friendly, so maybe you have to land that in something like a Hadoop system before landing that in your warehouse or transforming it to get into your warehouse. And then with these systems, there's a limited number of available slots for running work at the same time. So ultimately, you have to do things like create data marts, instantiate those in different systems, and push the users off there so that they aren't eating up all the horsepower that exists in the DW. Scale and speed issues, again, when you're looking at these data warehouses that are this shared nothing architecture that has existed for years and years, there is a limited number of concurrent query slots in that system. Chances are when you have high concurrent workload, there are people who are actually going to be waiting for their work to run. When you want to scale that system, you want to get more data in there than you have capacity for, you are inherently scaling all parts of that architecture, both compute and storage. Same goes for compute. You need more compute, but you don't need more data. Guess what? You're buying more disk anyway. That's the way it's going to be. As you can imagine, when you're buying capacity in pieces of the hardware that you don't necessarily need, this can result in the cost of the solution getting a little bit more than you may want it to be, and certainly having it in multiple places isn't really helping in that regard either. And all of the above here results in slow and limited decision making. Where is my data? Where do I have to go to get it? What do I do with it? So drilling in a little bit more on these 4 impacts here. So siloed diverse data, I mentioned this, and really the big driving force behind data being diverse nowadays is that the internet has come of age. There is web data coming from everywhere. There are IoT devices on manufacturing lines. You probably have a number of apps on your phone that organizations are mining all kinds of data about what you're doing. Fitbit, for example. All of that healthcare information, that's getting sent off to a data warehouse somewhere, and someone is looking at that information. Is all of that data together in one place? Probably not. Scale and speed issues. This is so a little bit of background on me. Prior to my career here at Snowflake, I spent about 8 years at IBM and Netezza. This is a problem I saw every single day. When you buy a data warehouse appliance in a shared nothing architecture, you effectively are dressing for the coldest day of the year all year round. You go, what is my peak workload going to be 3 years from now? Let's plan for that so I don't have to buy new appliances and step along as we move to that point in time. And so this chart right here, you kind of hit that ceiling right here. Let's see if I can get the mouse over there and actually see it well. There we go. You hit this point right here where you've kind of hit that capacity ceiling on your current box. You are upgrading that whole thing. You're purchasing a new box. You're migrating all of that data over. And frankly, by the time you actually get to use that compute that you've purchased and you've decided to move on, chances are about 3 months have gone by where you've done that sizing exercise, you've had the box shipped to you, you've installed it, you've moved your data over, you've regression tested, and all of that fun things that occur when you upgrade existing appliances. Costly, complex infrastructure. We talked already a little bit in the earlier slide about how there's a lot of hardware cost involved in something like that. But when you look at these systems as well, there's certainly a lot to be said as far as total cost of ownership is concerned. So in something like an appliance, in something like a Netezza, like an Exadata, like a Teradata, even things like Redshift, things that exist in the cloud, although these cloud data warehouses have taken off the onus on you guys to own and manage that hardware and keep that up and running, you still have to do a lot of care and feeding to ensure that system runs well. So you're building indexes, you're generating statistics, you're vacuuming when you delete data. All of these different things just to make sure that the lights stay on in that system and that things continue to run the same tomorrow as they do today as they did yesterday. A lot of work to be done on that. And just out of curiosity, anyone here an Oracle user? Anyone use Oracle before? I'm going to pick on them a little bit, but this isn't just an Oracle problem. That second piece right over there, licenses and hardware, think about the support cost you pay on these things year over year. You pay IBM $1 million for an appliance. Guess what? You're paying them $200,000 every single year just that you have a voice on the other end of the phone when you're having an issue with that system. Not an inexpensive proposition there. And again, slow, limited decision making. Because you have to limit the amount of data you're bringing in, you have it in different places, that restricts what you're able to look at in concert with one another. It makes it difficult to look at data from different sources and really join that up and see that holistic view of the data that your organization is collecting. And concurrency, oh boy, this is a big one. You have an appliance, you have a limited number of query slots that exist in that system. When user number, say in Netezza, user number 49 comes along and runs something, guess what? He's waiting in line. If you get to month-end reporting for finance, people are doing the 10K report, something like that, we're not talking about 48 users anymore, are we? We're talking about a heck of a lot more than that. There's going to be a lot of people waiting. That's going to slow them down. It's not necessarily going to make your business very happy. So, Snowflake. What's our primary goal? Enable every organization to be data-driven. Reduce barriers to looking at all of your data in one place and allow you to look at all of that together and make decisions that will shape your business on your full spectrum of data that you have available. So I already gave away a little bit of this slide here, but we'll go through it here now. So as I mentioned, 2012, a couple of Oracle guys who spent 20 years at Oracle working on Exadata, they looked at Azure, they looked at AWS, they looked at Google Cloud, and they said, wow, effectively speaking, we have infinite resources available. If we meet a customer who can tank S3 and completely load that thing, I would love to meet that customer. That would be a really fascinating thing to see. So they looked at that, they said, hey, if we could build a data warehouse that takes advantage of these infinite resources and does it well, that would be a game changer. So they went up to the powers that be at Oracle and they said, hey, we have this great idea, and they got the door shut in their face. So they locked themselves in a closet for about 2 years. They worked on building out Snowflake. And the one thing that I want to point out here is that Snowflake is not a derivative of a different data warehouse system. This was completely built from the ground up to take advantage of the cloud. This is not a data warehouse appliance that has been migrated. It's not a Postgres derivative. It's not an Oracle product. Snowflake is Snowflake. 2014, product was done. We got to our first customers. We went officially GA in 2015. At this point now, 2019, we have generated nearly $1 billion in venture capital. We have somewhere in the neighborhood, I love this one on the end here because we say 1,500. This slide cannot keep up with how many folks are signing on with this thing. We could probably easily say 2,300 plus at this point. The growth rate has been insane. We are in those nice top right quadrants in both the Gartner and the Forrester reports at this point. And we're living the life out here. So what are we offering that has allowed us this success here? Unique architecture designed for the cloud. So all of your data centralized in one location. I mentioned those Hadoop systems that folks have historically used. When I was at IBM, I was a big data practitioner in addition to a data warehousing practitioner. Probably about 80%, 90% of the use cases that I saw for something like Hadoop involved, hey, I have this massive JSON feed coming in, and my data warehouse can't take that in. Or if it can, it's a pain in the butt. I got to put it into a varchar, I got to put it into blob, I have to stitch all these rows together, I have to use these unnatural functions. At the end of the day, it's a pain to actually get value out of that data. So, oftentimes it'll get in and then it'll just sit there and folks don't know what to do with it, but it takes up space in that gold-plated appliance. Unlimited automatic scale and speed. unlimited scale. In Snowflake, there you are loading data. You do not have to worry about hitting that ceiling on how much storage you have available. You just keep loading and loading and loading, and your data is either landing in S3 if we're talking AWS, it's landing in blob storage if we're talking about Azure. We're going to be on Google Cloud later this year as well. Because we're not on there yet, I don't quite know all of the architectural pieces, but they have a great storage mechanism as well. Keep loading data. There's nothing going to stop you from loading as much data as you like into Snowflake. Just keep going and going. On the compute side of things, it's much the same thing. You have 10 users, you have 1,000 users. We can accommodate all of them, and we can accommodate all of them simultaneously. And as a result, we can also isolate all of these separate workloads. And in my next slide, I'll actually talk a little bit more about how ETL and BI can coexist and don't have to fight with each other over resources at all times anymore. Simple, cost-effective infrastructure. There are 2 metrics for pricing on Snowflake. One, how much data am I storing? We compress your data when you ingest it. If we're talking about relational data, we typically see about 5x compression. If we're talking semi-structured data, we usually see more like 20x compression. So getting that data into Snowflake, into our S3 containers where we apply all of our magic, you typically save about 5x over storing it in S3 raw. $23 per compressed terabyte per month. My biggest customer in Boston has about 2.5 petabytes of data in Snowflake. If that was living somewhere else, that would be somewhere in the neighborhood of actually 20 petabytes because over half of that is JSON. And as a result of having all of this data co-located, you can make decisions based on all of it, and you can do it as quickly as you like. So, how do we do all of this crazy stuff that I'm talking about here? So we have developed a 3-tier architecture, and the most important thing to point out about this architecture is that compute and storage have been separated from one another. You look at these systems that have existed for the past 20 years, you look at this shared-to-nothing architecture where you have a certain disk drive tied to a certain CPU core, and you probably have those spanning about 100 different units of that. You're locked into that size of that system, and if you write a query that is either the data is poorly distributed or something like that, you can run into situations where 1 or 2 of those hundreds of cores that you have end up doing all of the work. Not a very efficient way of taking advantage of that. So we have taken compute and storage, and again, they are separate from one another. Storage layer at the bottom, Azure Blob Store, Azure or AWS S3, whatever the Google one is. Again, I don't remember that one yet. Second layer, the compute layer. Not only is compute separate from storage, compute can be separate from compute. Okay? So you see here on this slide, we have 3 little semicircles on this thing. We have loading, we have ad hoc analytics, we have development. This isn't, a kind of a prescription of the 3 warehouses that you set up in Snowflake. It's kind of an example here. But let's talk about, say, loading, data science, and business reporting, just as an example here. Usually you have those things happening at the same time in a data warehouse appliance. You're taking a pie and you're cutting it up into smaller and smaller slices depending upon how many folks are accessing at a time. Maybe you have folks who are wizards and who have done a great job doing workload management and make that a little bit less of a struggle. But, in my 10 years of doing Netezza, I didn't find many folks doing a particularly good job with workload management. It's not an easy thing to get your hands around and really make work well. So, here in Snowflake, we can have a cluster for loading data, and that can be running all day long. It can run for your usual overnight batch window. When you are using this thing, you pay for the seconds that this cluster is up and running. And when you are done loading data, you shut that cluster off and the billing stops until you next need to turn it on. Now, if that's happening all day long, certainly we're ACID compliant. You're going to have transactions committing to ensure that the reporting users are actually seeing live up-to-date data. But that loading activity is in no way going to impact the compute that BI is using to satisfy their queries. The top layer of this architecture is our cloud services layer, and this is what allows us to do all of this without you needing to manage the system, without you needing to build these indexes, generate statistics, vacuum, all of these other things that have historically spent most of your DBA's time spending on just, again, keeping the lights on. It's care and feeding stuff. It's not really adding a lot of value. So metadata manager is probably the most important piece. That's the one on the right on that top layer. This is really how we keep track of where all of your data has landed in the storage layer of Snowflake. When you create a table, we create hundreds or thousands of micro partitions on that storage layer. The metadata manager goes, okay, we have this customer table. All of these partitions I created are that customer table. What are all the min-max values in those? What's all the kind of indexing information that's on those, such that when you run a query and you're looking for a particular customer ID, a particular date range, something like that, we have all kinds of metadata around every partition we create, such that we are only retrieving those partitions that are relevant to the query that you're running. couple other things that I want to point out here with regards to loading data in particular. So something that I used to see all the time when we're talking about loading data in a data warehouse appliance is that the only time we can get all the kids out of the pool is from, say, 1 a.m. to 4 a.m. or 1 a.m. to 5 a.m. because I like 4 hours. That's easier for me to work with. So, Natiza, you load from 1 a.m. to 5 a.m. You get that data in. If you have more data that day, if there are challenges that occur with that loading activity, if that has to spill over to 6 or 7 a.m., people are going to be impacted negatively on the reporting side, either from a horsepower standpoint or a preparedness standpoint. Now in Snowflake, if we look at your loading cycle and we figure out, hey, we can use a 2-node Snowflake cluster to load that data in 4 hours. So 2 nodes times 4 hours, that would be 8 node hours, and that's what you would be billed on in that case. Here's the really cool thing. These clusters scale linearly, and they scale up by 2 every single time you move up the line. So we figure out that 2 nodes in 4 hours will do that activity in the same window that you guys have gotten used to. Okay, let's use a cluster that's 4 times as big. Let's use an 8-node cluster. Now we're getting that job done in 1 hour, and that job doesn't cost any different to get done. The cost of doing that is the same because we are still using 8 node hours to accomplish that activity. Okay? So this window that you have been locked to, what we can do is we can determine what is the maximum size of cluster that we can use before we're not loading enough data to actually blow that one up and see that linear scaling. And then we go, okay, great. We can use a 3XL, a 64-node cluster, and we can get this whole thing done in 5 minutes, and then we can shut it off, and then we're done for the day. We can be doing reporting or other things overnight if there would be value in doing that. Again, loading data all night long while BI is going on is another pretty neat thing. If you are using some of the more streaming-related things from Talend, being able to point that at a warehouse and just let that run all day long. You may be able to use an extra small cluster, 1 node, have it on for a few minutes here and there throughout the day. And that data can be coming in live. You don't have to be kind of locked to that batch window anymore if that's not the way that you want to take things. All right, so a couple more unique capabilities, and if you guys are seeing these data sharing for dummies books on your table, these next couple of slides are relevant to that. So real quick on this one. If you're using Snowflake, you are in a multi-tenant environment, okay? So all of your data is going to be completely logically separated from everyone else. All of your data is encrypted with a key that is unique to you. All of your data moving back and forth is encrypted with a separate key unique to you. If you're enterprise for sensitive data, your queries moving around are all on a key that's unique to you. But at the end of the day, all of that data is going to be existing in the same S3 bucket. And the top layer there is going to span all of these accounts in that region. So the metadata manager, it has information specific to you. It has other accounts in the same region. So what can we do by abusing this combination of things here? Oh, I got a little bit closer to the mic there. Sorry about that. So in Snowflake, you can share data where appropriate. If you want to monetize a certain data set that you analyze, you work with another organization, they ship you data, you ship data back to them. Think about the way this has historically had to be done. You unload data to a hard drive. You unload it somewhere, maybe an S3 bucket, maybe an FTP site. You spend some time pushing that data up there. Your customer grabs that data, maybe it's on a hard drive, maybe they pull it off an FTP, they load it into their data warehouse. By the time they're actually looking at that data that you provided to them, maybe a week's gone by, and it's not really up-to-date data anymore. So in Snowflake, we want to not only allow organizations to be data-driven internally, but if there are data sets that are relevant to them outside in other organizations, be able to operate on that live as well. So here's what we do. You, as a Snowflake data provider, pick a data object. Maybe it's a database, maybe it's a table, maybe it's a secured view that you have built on a particular set of data because you just want to expose a few rows of a table to a customer of yours. You say, I want to expose this data set to this other Snowflake account in the same region as me. On the receiver side, or on the consumer side rather, they would see a database object that is now incoming, and they can define, they give it a name on their side, and now they dictate, okay, these users have access to read that. They are not paying for the storage on that. It is stored in one place. You have a set of metadata pointers in your account. You have a set in theirs. It's looking at the same data behind the scenes. So you pay for the storage bill. They may pay for the compute. If you have a customer you want to share with that is not a Snowflake customer, you can give them what we would call a reader account, and then you can, they basically use your compute credits, and in that case, monetizing that becomes even easier because you know exactly how much they're spending there. And yeah, you're able to give them live data. They are looking at that as it exists in your account at that point in time. They're not looking at something that they received on a drive, loaded, and it's a week old at that point. We see a lot of organizations white-gloving data, building out specific data sets and sharing it out and turning that into a revenue stream rather than just a cost center. We, Snowflake, actually use this with one of our SIM vendors to analyze our security data. We put all our logs in Snowflake, we ship it to them, they analyze it, make their own database, share that back to us. A process that we used to get audited and it would take us about 2 months to kind of complete this audit cycle, it now takes us 2 hours because we're able to do it live whenever we want to. How to share data? Again, we talked about this. Collaborate on this shared data with your partners. Enrich your analytics with data from other sources if you want to bring it in. If you're looking at what we are intending to do with this in this coming year, beyond just being able to share between accounts, we're going to be having a data marketplace where organizations that have data that would be broadly applicable beyond just, hey, I want to share my set of data with, I'm a CPG company and I want to get data from one of my suppliers, something like that. There are organizations that have weather data, that have healthcare data, that have other data that might be relevant beyond just that one-to-one relationship. And so building a marketplace to do that, that's one of our goals here, enable this kind of data economy that's really becoming the front runner here. So that about wraps up what I had to say here. So thank you.